Welcome to another day on the Journey Chez Chem. This is a new topic, so you may have to look in a textbook to find the answers. And I'll see you in a moment. Number 1 asks, what is nomenclature? Well, that is an interesting question. Nomen in Latin means name. So this means, how do we name compounds? These are the rules for naming compounds. Now, the two characteristics given in a formula, if we take a look at H2O, we see that it's composed of hydrogen and oxygen. So one of the things in a formula are the elements that the compound is composed of. The second thing is the relative amounts of each element with regard to one another. We have 2 hydrogens for 1 oxygen, so it gives us the ratio of those elements in the compound. Now, you got 3 sheets yesterday. One was a sheet of the brochure, and we're going to give a couple. So in week 9, day 2, that brochure, do this before we can write a brochure about it. So in week 9, day 2, that brochure will be due. And on that same day, we'll have a quiz on the polyatomic ions. If you look at the sheet that has a coyote on it, it has a list of 23 polyatomic ions. And it's very much like the elements quiz, where you will have to give me either the polyatomic ion with its charge or the name. So you have to be able to go back and forth. So I suggest that you start learning those a couple of nights and you'll have it down, no problem. The third sheet we're going to go over together because it's very important that you get these beginning rules. Now on the other side, or on one of the sheets, you have a bumblebee, and that's the rules for naming compounds. And the very first rule states that all compounds have an overall charge of 0. And we're going to come back to that very often. So please get the worksheet naming compounds out, and we'll go through that together. In the naming compounds worksheet, there are little descriptions of how to do these problems. So I suggest that you try to read these over and see if you can understand what information is given to you. These are binary compounds. They are compounds composed of 2 different elements. And the second element takes on the ending IDE. Now, so the first one is just magnesium oxide. The second one is barium sulfide. The third one is potassium nitride. Now you'll notice that there are 3 potassiums here, and that is because potassium always has a charge of +1, and nitrogen is -3 when it's in the negative position. So compounds have to be 0, so I must have 3 potassiums to get to 0. And number 4 is sodium fluoride. Now number 5, a good habit to do is to write the charge above the element. And potassium is +1 and chlorine is -1, so it's just KCl. Calcium is +2, oxygen is -2, so it's just CaO. Magnesium is +2. Phosphide is -3. So the common multiple here is 6. So I have to multiply the magnesium by 3 and the phosphorus by 2. Lithium is +1 and nitride is -3. So it should be Li subscript 3N to get to 0, because +3 and -3 is equal to 0. That was the first part there. Unless an element is an alkali metal, an alkaline earth metal, or one of the silly 6, it can change. When it changes, it must have a Roman numeral to tell us what it is. We can tell that by looking in the formula and seeing how it's written. Otherwise, in words, it has to give us a Roman numeral. So in number 9, we look at the negative position, and chlorine is -1. There are 2 of them. So that gives me a -2 on the chlorine. Compounds are always 0, so iron must be Roman numeral 2 or +2. Bromine is -1. Therefore, tin must be +1. Tin, Roman numeral 1, bromide. Now, it is very important that you put the Roman numeral 1. It is not understood like many math problems are. You must have the Roman numeral. Otherwise, we wouldn't know what the charge was. Sulfur is -2. And compounds are 0. Therefore, nickel must be +2. Roman numeral 2, sulfide. And it endings in IDE because they're binary compounds. They're composed of 2 different elements. So the second element takes on the ending IDE. In number 12, we're going from words to formulas. This Roman numeral 3 is telling me that iron is +3. Iodine is -1. The lowest common multiple between 3 and 1 is 3. Well, iron is already 3, so I need 3 iodines to get to -3. +3 and -3 is 0. Roman numeral 4 is telling me that tin is +4. Oxygen is -2. Common multiple, 4. SnO2 to get to 0. Roman numeral 2 says that lead is +2. Chlorine is -1. Lowest common multiple is 2. Lead is already 2, so I need 2 chlorines to make lead 2 chloride. And that's that section. In this case, we have nonmetals combining with nonmetals. So there's 2 options of what we can do. We can use the Greek prefixes mono, di, tri, tetra, penta, hexa, hepta, nona, deca, or we can use Roman numerals. Now, personally, I prefer Roman numerals, and I will always give it to you in the Roman numeral form. But we need to be aware of those prefixes. So first, I'm going to quickly go through the prefixes. 15 is carbon monoxide. We do not say monocarbon monoxide. If there's only 1 atom to begin with, we do not say mono. However, the second atom, we must say how many there are. 16 is sulfur dioxide. So the prefixes relate to the number of atoms. 17, dinitrogen pentaoxide. 18, carbon dioxide. 19, carbon tetrachloride, and 20, sulfur trioxide. Now, I don't use the prefixes because you need to continually practice how to do those Roman numerals because they're the challenging ones. So we'll work on those together. Oxygen has a -2 charge, and carbon is what I'm trying to find. So this would be carbon Roman numeral 2, oxide. Oxygen is -2, times 2 is -4. Compounds are 0, therefore this is sulfur, Roman numeral 4, oxide. Oxygen is -2, times 5 is -10. Now in this case there are 2 nitrogens, and we always want to know the charge of a single atom, and compounds are 0. So this is nitrogen, Roman numeral 5, oxide. Oxygen is -2, times 2 is -4, and therefore carbon is +4. Carbon, Roman numeral 4, oxide. Now I know that we always call it carbon dioxide, and that's fine. I'll accept that on the assessment. But when I give it to you, I'll give it to you with Roman numerals, so you do need to understand both ways. Chlorine is -1. There are 4 of them. That gives me a -4. There's only one carbon and compounds are 0. So this is carbon, Roman numeral 4, chloride. Oxygen is -2, times 3 is -6. Compounds are 0, therefore sulfur is +6. Sulfur, Roman numeral 6, oxide. So that's how we do it with the Roman numerals. Now you have a variety of different problems to do with polyatomic ions, and we'll do those next. Now, a polyatomic ion is a group of elements that's joined together with a covalent bond. They're sharing electrons and they have an overall charge. So we need to understand and be able to recognize those. There are 23 on the polyatomic ion worksheet that you need to memorize. And we'll have a couple of weeks before we take a quiz on that, but it's very important for you to learn those as quickly as possible. Now these problems have the polyatomic ions in them. So we have barium hydroxide, sodium carbonate. So the polyatomic ion name does not change. It stays the same. Now this one is hydrogen peroxide. In this case, peroxide has a -2 charge. Therefore, each oxygen is -1, and that's an unusual thing for oxygen. And we know that hydrogen peroxide is very reactive. That's why we use it when we pour it on our wounds and it bubbles, because it's very reactive. So it's not your normal oxygen. Sodium chromate, well, chromate is -2, and sodium is +1, so I still have to balance formulas so that they come to 0. Na2CrO4. Nickel is +2. Acetate is -1. Compounds must be 0. Ni, parentheses, C2H3O2 twice. Now it's very important when I have more than one polyatomic ion that I put it alone in parentheses, and there are 2 of them. So -1 times 2 is -2. And nickel is +2, and that brings me to 0. Ammonium iodide. Ammonium is our only one that has a +1 charge. And iodide is -1. So it's just NH4I. And that's how we do them with polyatomic ions. Again, I must reiterate that polyatomic ions are critical for you to learn. I suggest you do a couple a night, and then you'll have it no problem. Well, that was some fun, and I'm hoping that you understood this, but we'll try it. We'll have it for a while because this is a very, very important topic. So you have some practice tonight, and we'll see you tomorrow.